In this lesson, we're going to look at how we can factor simple trinomials. So we've taken a look already at how we can take two binomials which are being multiplied by each other and end up with a trinomial as our answer. In this video, we're going to learn how to do the reverse, how to start with a trinomial and factor it into the two binomials that multiply to it. So we're going to look at some different patterns that we can see. So first of all, a simple quadratic trinomial has an equation of y equals ax squared plus bx plus c. So in today's lesson, a is always going to be 1, so we'll see no number there. Remember, when we have a coefficient of 1, we don't have to write it. So we're going to see x squared plus bx plus c. So we'll have some number here and some number over here. When we factor a trinomial, we're going to end up with two binomials or two sets of brackets. So we're going to end up with an x plus or minus some number and another bracket, x plus or minus another number. So we'll start by working backwards, which is what we originally learned, is how to take two binomials and multiply them. We'll end up with 4 terms, but the middle two are like terms, which we can collect, and then that leaves us with a trinomial. So we're going to use that to see if we can help us to figure out how we can factor a trinomial. So over here we have x plus 2 times x plus 5. So remember, I'm going to start with the first term in my first bracket, that's x, and I'm going to multiply it by each of the two terms in my second bracket. So I have x times x is x squared, x times 5, both of them are positive, so it's a positive 5x. I have a positive 2 times a positive x. The next thing I'm going to do is pick the second term, because now I'm finished with the first term, and I'm going to multiply that through by each thing in the second bracket. So 2 times x is a positive 2x, and then 2 times 5 is a positive 5. So there is my 4 terms when I multiply my two binomials, but my middle two terms are like terms. I have a plus 5x plus 2x, so that's equal to plus 7x. So I'm going to rewrite my x squared. I'm going to collect my like terms to get 7x and rewrite the plus 5. So there is my trinomial. Oh, sorry. 2 times 5 is not 5, it is 10. Okay, so what I want to do is see if from these two lines I can see anything to help me figure out, if I'm starting with a trinomial, how do I figure out what my two binomials are in my bracket. So if I look over here, to get x squared comes from x times x. So I know that the first term in each bracket is going to be an x. Then I'm going to have plus or minus some number and plus or minus some number to get my second term. So binomial, remember, two terms. So over here, when I look at this, I have a 7x and a 10. If I look at this line, this number is still 10. This just comes from the last two terms in each binomial, or the two numbers, and they multiply to 10. So whatever this last number is, these two numbers multiply to it. Over here, because we have a number times a 1x, we're going to end up with that number in x. So 5x and 2x. And then the 5 and 2 add to 7. So when I'm working backwards, when I'm starting here and I'm trying to figure out the brackets, I'm looking for two numbers that multiply to 10 and add to 7. And 2 and 5 are those numbers, and they're both positive, so I'd have a plus 2 and a plus 5. Okay, let's look at another example. See if that same thing happens. So I have a times a, that's a squared, a times negative 1 is minus 1a. Negative 3 times a is minus 3a. And negative 3 times negative 1 is a positive 3. Then I will collect my like terms here. So I have a squared minus 1 minus 3 is minus 4a plus 3. So I want to see two numbers that multiply to 3. So 3 and 1 multiply to 3, and I need to add to negative 4. So negative 3 and negative 1 add to negative 4. So it looks like our pattern worked again. Let's try with one more. So I have y squared minus 2y plus 3y minus 6. Combine the like terms. So I have y squared plus 1y, or plus y, minus 6. So 3 minus 2 is equal to 1, and 3 times negative 2 is equal to negative 6. So what we can see is that we are always adding to whatever the coefficient in front of our y or our x term, whatever has just the, not the squared, but the variable. And then we are multiplying to our constant. So our c value, so that was, remember, we have y equals ax squared plus bx plus c. And right now we're talking about when a is equal to 1, so we don't have a number in front of our x squared. So with the c value, what we see is that the two constants, so the two numbers from our binomials, they add, sorry, wrong one. These ones, they multiply to the c value. And with the b, so the number in front of our variable, they add to that. So let's try to work backwards then. So we're looking for something that multiplies to c and adds to b. So first thing we want to do then is we want to identify our c and our b. So those are the numbers. So the number in front of the x, that's our b. So our b is equal to 3, and it's a positive 3, so we want to add to positive 3. And then our c is equal to a positive 2, so we want to multiply to a positive 2. So we're going to look for numbers that multiply to 2 and add to 3. So 2 times 1 is equal to 2. And if I take those same two numbers, 2 plus 1, that equals 3. So that works. Now we don't have a lot of options multiplying to 2. Only 2 and 1 multiply to 2. And they happen to add to 3, so we are good here. So those are our two numbers then. 2 and 1 are the two numbers that go inside of our binomial. So when I am factoring this question, I'm looking for two sets of brackets, two binomials. I know that the first term in each bracket is x, because to get x squared, I need x times x. So this system helps me find that my other two terms are a 2 and a 1. It doesn't matter what order I write them in. And because they're positive, I'm going to be adding them. So I can check this. X times x is x squared. X times 1 is 1x. 2 times x is 2x. And 2 times 1 is 2. Then we have our 1x plus 2x. And that's 3x. and then plus 2, and we're back to the original. So this is just a check to see if we got our binomial correct. Let's try another example. So this time we have a b value of -5 and a c of +6. So c equals 6, so I need to multiply to +6, and b equals -5, so I need to multiply to -5. Sorry, add to -5. Okay, so I'm always starting with the c, multiplying to the c value, because there's only so many numbers that will multiply to the c value, but we can add to get -5 in an infinite number of ways. So we're always starting with c, what we multiply to. So numbers that multiply to 6, 1 times 6 multiplies to 6, and 2 times 3 multiplies to 6. Now if I do 1 plus 6, that equals 7, and 2 plus 3, that equals 5. Now, the 2 times 3, 2 plus 3 equals 5, so that's good. I need 5, but I need -5. So to get to -5, I actually need to use negative numbers. Now, if I'm multiplying to a positive number, I can only get that by having 2 positives or 2 negatives. So let's try -2 times -3. And -2 subtract 3, that is equal to -5. So this is the one that works out. These don't give us a -5, so they're not the right numbers. So that means our two numbers in our binomial are a -2 and a -3. So this is going to equal x minus 2 and x minus 3. And let's try one last example. So I have a b of +3, a c of -10. So I'm going to start with my -10. c equals -10, so I need to find something that multiplies to -10. b equals 3, so I need to find something that adds to 3. Okay, so to multiply to -10, I'm going to need one positive and one negative. So -1 times 10 is equal to -10. -1 plus 10 is equal to 9, so that's no good. -2 times 5 equals -10. -2 plus 5, so 5 minus 2 is equal to 3, and that's what I need, a +3, so I am done here. And those are my two numbers, so -2 and a +5. So this trinomial is equal to x minus 2 and x plus 5. So once again, we can do a check. So x times x is x squared, x times 5 is +5x, -2 times x is -2x, and -2 times +5 is a -10. Then I'm going to collect my like terms. So 5 minus 2 is a +3. And that gets me back to the original trinomial. So this is just a check to tell me that I got the binomials correct.